Okay, so our first problem, the kayaker travels 2 miles upstream, 3 miles downstream in a total of 5 hours. The average speed of the current is 2 miles per hour. In still water, what is the average speed of the kayaker? What is the speed of the kayaker when they traveled upstream? So this problem is a current problem. And we set these up as time is equal to distance over rate minus the current. So this is when we're going against the current or upstream, plus distance over rate plus the current. So this is when the current's helping us, we're going with it. So in this case, it took 5 total hours, traveled 2 miles upstream, so 2 miles rate against the current of 2 miles an hour, plus 3 miles downstream when he had the current at the kayaker's back. So rate plus 2. So rate against the current, rate with the current. So now we just need to find a common denominator. So the least common multiple of r minus 2 and r plus 2 is simply the 2 multiplied together, r minus 2 times r plus 2. So we have to get each of these rational expressions to this common denominator. And the way we do that is we multiply each rational expression by the factor it's missing. So this would be 5 equals, since this is r minus 2, it's missing the r plus 2. So we'll multiply by r plus 2 over r plus 2 times 2 over r minus 2. And then likewise, here I'm missing the r minus 2 factor. So I'm going to take my 3 over r plus 2 and multiply it by r minus 2 over r minus 2. Now remember, r minus 2 over r minus 2 equals 1. So we're not changing the value of this rational expression. We are merely changing the form to get to this common denominator. So then we set these, we simplify these, and we have, remember to distribute the 2 to both terms. 2r plus 4 over r squared minus 4. So r plus 2 times r minus 2 is simply r squared minus 4, plus 3r minus 6, r squared minus 4. Now that we have common denominator, we can add our numerators together. So we get 5 equals 5r minus 2, so 2r plus 3r, 5r, 4 minus 6 minus 2, r squared minus 4. From here, we need to get rid of this denominator, and the way we do that is we're going to multiply both sides by that denominator. So I'm going to come over here and I'm going to go r squared minus 4 times my 5 is equal to 5r minus 2 r squared minus 4 times r squared minus 4. So over here, since the factor is now in the numerator and the denominator, they cancel out. Here, I need to distribute my 5 to both terms. So I have 5r squared minus 20 equals 5r minus 2. Now, since we have a squared here, we've got a quadratic going on, so I need to set this equal to 0. So I'm going to subtract this from both sides. 5r squared minus 5r minus 18 equals 0. Now here, I have a couple different options. I could try factoring by grouping and see if I could do that. I could use my quadratic formula, or I could graph this and find the zeros. So we're going to just graph it and find the zeros. Okay, so I've plugged in my function, my 5r squared minus 5r minus 18, into the calculator under the y equals. If I hit graph, there's the graph of my function. Now to find my intercepts, my zeros, second trace 2 for 0. So come over here. So there's my left bound for my first, enter, come below, enter for my right bound, enter again. So I have my first x as x equals negative 1.462. And I'll do this again. So second trace, 0. This time I'll bring my cursor over until it's over here on the right side, still below for the x for the left, enter. Come above for the right, enter, enter again to guess, and I have x equals 2.462. Now, can we have a negative current? No. This would mean that the current would be pushing you upstream. So we will drop that one. And so our current, I'm sorry, not our current, our average speed of our kayaker in still water is 2.462. We can't have a negative speed. That means he's rowing backwards. Sorry about that. So this is our average speed of our kayaker. Now, it also asks, what is the speed when the kayaker traveled upstream? Well, we know the current right here, his speed's going to be his average speed here minus the current. So 2.462 minus 2, or 0.462 miles per hour. There's our solution. And if we wanted to, we could double check this. If you take this 2.462, which is the kayaker's average speed, his rate, and we plug it in for the R's, plug it in for this R, plug it in for this R, solve these two fractions, you would end up with 5. So average speed in still water, 2.462 miles per hour. Average speed upstream, 0.462 miles per hour. So a little under half a mile an hour, pretty darn slow.